Hello, good morning, good afternoon. I'm checking the sound, the mic is on. Okay, so a big improvement from the last time. Today I will have a shorter period of time for the stream. So let's get to work. Last time we finished, I concluded the stream at the phase when I sent the schematic to the BV circuits for an approval, not approval, for a schematic check. And today I will have a very brief review of the schematic, mainly for myself, because it's been a week and frankly not everything is on the top of my mind, so yeah, I need to refresh myself, and then we will dig into the BV circuit review, and I will go point by point and I will discuss each of them. And I estimate 30 plus points. Usually big designs have 20 to 30, 40. Yeah, of course, it depends on the design quality, and I did my best. But I learned a lesson last time. I made a mess with the labels. So next time with the buses, definitely I will use a better names. I will use better names for the labels. For instance, if you check the schematic setup, here is the bus alias definition. Boot 0 to 3 is okay, but for instance here, the Ethernet, there are some, Ethernet reset. I think I renamed the signal last time, but ideally I would start each member label name with ETH1. So ETH1 underscore TXD0 or ETH1 underscore MDC, because it brings the quality, and it ensures that the names will be mixed with another block, because there is always an issue and a risk of mixing label names. And I'm sorry. Yeah, okay, that's my cat. So yeah, you understand probably. If not, I will dig into that deeply later. So, or deeper later. This is the power entry with the E-fuse. The result is 5 volt in. It goes to PMIC plus this buck converter. The PMIC mainly powers the MPU here in this block, and other blocks like SD card, which is here, some peripherals, which are only buttons, LEDs, and boot switches. DDR is supplied from the PMIC. Ethernet is supplied from the auxiliary buck, not auxiliary, from the buck converter, 3.3 volt, and M2 is supplied from 3 volt 3, as well as from the PMIC, which is VDDA 1.8. Let's say this M2 connector side of the voltage translators is supplied from PMIC, and the MPU side is supplied from 3 volt 3. I think there is not Yeah, only 2 power domains. Okay, so let's get to the BV circuits. Here is the PM circuits. Here is the dashboard, my, let's say, short history of reviews. I deleted majority of them, but some of them kept here. So here is the report. 15 issues, that's less than I expected, or fewer than I expected. Issue number 1, single pin unconnected nets. The following nets are connected to only 1 pin. I2C 2 SDA. Okay, so let's check it, and probably all of these are addressed. SDA, LCD, yes. Probably yes. All LCDs, yes. So I can combine the BV circuit results with the DRC. And yes, it seems that they use something like DRC. So I can go signal by signal, label by label, but based on the list, I can see majority of LCDs, SSD MMC, which is really here, SSD MMC3, all the cameras, and I2C 2 SDAs, and all LCDs, yes, audio, yeah, that's it. So I think it's okay. Helpful or not helpful? Let's say helpful, because yeah, definitely that's a correct finding, because when an engineer didn't run ERC in the KiCad, this will serve as a source of information. So, okay. Power supply pin connections on non-power nets. The following power pins appear to be connected to non-power nets in the net list: U36 and U7M6. So power pins are connected to non-power nets. Okay. Might be signal, might be symbol issues or other things, similar things. So U36, let's get to the schematic. U3 is here. U3 is LAN converter, and 6 is VDD-CR. VDD-CR, yes, this power flag is probably incorrect, because VDD-CR is, I think, the internal LDO output, and that's not connected to power. I want a pinout, pinless assignments here, or even here. It's VDD6, VDD-CR. It's in a mixed order, like symbolic order, not VDD-CR. Supplied by the on-chip regulator unless configured for regulator off mode via. Okay. So this is this is the internal regulator. Let me open the reference design schematic, because I take this reference design as a source of a correct information. Yes, that's only output of the internal regulator. So correctly, this power flag can't be here, and this is definitely a helpful issue when speaking of U3 and U7 M6. Probably a very similar U7 M6, U7 M6. It will be here in Power MCU. M6 is VBAD. VBAD is the power input, which is correct, and M6 is it's the M6 is power input, which is correct. So what's wrong with this symbol? Even though the RC is not pointing to that point, or ERC, I think that's false. That's false positive, or yeah, false negative, or how to say, like a false issue. That's power input, and this is power input, and this is potential power input, because it's to be connected, a battery to be connected here. So this is correctly marked as power flag. That's correct. Good luck. Yeah, thank you. Good luck is always helpful and needed. How are you? So helpful. The false negative issue is something that okay, I double checked the U7 M6. It's correct. Open drain nets, missing pull-up resistors. Okay, that's the unconnected, probably unconnected labels, but I will check them. Yeah, these two are unconnected. I3C1 unconnected, correct, and C2 unconnected. Yes, that's okay, because if these ports are used in the design, there must be 6 pull-up resistors. That's correct. Yeah, that's great. So you can offer the hardware review or schematic review services or PCB review services. That's very helpful. Thank you. Capacitor voltage derating. Voltage stress, yeah, that's important, because we sometimes forget to check the voltage rating of the capacitors. I usually double check it when placing the component, but yeah, never mind. We have to check it. C94. Which is VDD core, which is, I don't know, 0.8, and this cap is 6.3. I don't know why so many attributes are here. Yeah, I think oh, never mind. Yes, that's correct. this is this one as well. Yeah, that's because the schematic checker doesn't know the voltage level of the VDD core, so probably it supposes that 3.3 is the voltage and 6.3 is not in the range of acceptance, probably. C7. C7. Where is C7? Yeah, I think below this dialog. No. Where is C7? C7. I can't see C7. Where is C7? KiCad. C7. C9. C7 here. 6.3 and output is, I don't know, it's false. C10. Where is C10? I don't know. If I'm looking for something, I would expect to zoom into that component, and there is definitely C10. Yeah, the KiCad number 10 is a shit full of bugs. If there is some engineer who codes this piece of crap, go back to work, get to your desk and work your ass off and improve this shit. Thank you. Correct. It's correct. Bus index gap in tim8_ch_bus. The sequence is not continuous. Index 3 is missing. That's interesting. That's very interesting. Of course. Bus group TM CH bus. There is no such a bus. Is there some forgotten piece of imported schematic? No. No. Oh, they mean that this channel 3 is missing. Why? Multiple unsynchronized switching regulators on shared input rail. Yeah, the frequency is not synchronized, but the voltage sequence is synchronized. And yeah, there are no LC input filters, but yeah, we don't need it. Thank you. That's okay. That's okay issue. SA1C, SCTA, and SDB level shifter inputs appear unconnected. Let's check. Let's check. That sounds interesting. Yeah, probably because of the label names that are here. Yeah, that's because of the KiCad changed the labels, and the netlist contains probably the, I don't know, the original names, but the resulted, I don't know. Yeah, that's kind of helpful, but yeah, it's not applicable to this schematic. PMIC I2C pull-up supply availability during startup. Pull-up resistors are 6.7. PMIC 6.7. Probably this one, these ones. No. R6. Here. Yes. Yes, are tied to VDD, yes, which is a PMIC supply trail. If VDD-IO is not stable before I2C communication is attempted during startup, the bus may be in an undefined state or experience connection. That's actually a very good issue, a very good finding, because that's correct. When I supply the bus of the PMIC, or yeah, the bus level is an output of the PMIC with the I/O, and if I somehow lost this voltage, I can't communicate with the PMIC. That's indeed a very good issue, very good finding, as well as this VIO. I'm going to check the datasheet for VIO 31. IO voltage. For all digital signals. VIO. Here. Yeah. 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 Because I'm not a shooter, I will do this. Yes. This one, and I will do the same with the, I will create another one with this one, because I really think that this is a very valid and serious finding. Because it doesn't matter that the default output of the, where are the default outputs? Here. The default output of the LDO2 is 3.3, but I think you can disconnect it. Let's check it. Yeah. This finding is valid if the LDO2 can be disabled from the PMIC. Let's check it. Okay, let's try this. Okay, so Leo AI is not free anymore. Never mind. Let's use Notebook LM. It will index the PDF in a second. Do. Faster. It's not so long. Come on. Okay. No. Yes, can be disabled. Independent control, including LDO2 metals. Software, automatic, power control. Yeah. So can be. Let's double check it. The same question, can the LDO2 be disabled? Faster. Yeah, the same answer. Great, so it's confirmed. I definitely think that this improves the design. Yes. Definitely great point. Very helpful. Large RC time constant on ADC inputs may impair settling. Which is, yeah, but that's from the original design, so I think it's okay. Yeah. Thank you for the concern, but the USB-CC is not a, let's say, fast changing signal. It's like constant voltage when connected to the port, and it's pretty stable. But okay, it's valid. No debounce filtering on an reset, but on a C3. Yeah, that's an usual thing. This one. Yeah, and speaking of the bouncing, it can be even capacitor, which is I think here. Here is the capacitor, and I don't know. I think it's correct. I think it's correct. Oh, sorry, I'm back. So yeah, the debouncing is not explicitly there, but the circuits create RNRC filter already. 10 nanofarads can be too much, but the original design says, where is the reset thing? Where it is? And reset is here on the here is 10 nanofarads, and we can check the maybe datasheet, maybe sometimes in the datasheet there's here 10 nanofarads, which is a recommended value. There is weak pull-up inside 40K. I think it's correct. I think it's correct. The finding is okay, or helpful, because I double checked it and I'm pretty sure now, so helpful. No debounce temp, yeah, but the same issue, but temp is here. Okay. Why not? I can place it here. A cap. Here. Okay. That's better. One thing, One thing, KiCad version 10 brings the version control, Git tracking, and at first I enabled this, but what happened? KiCad started creating .history hidden folder in my project folders and started storing the project files inside of the .history folder. So there are backup folders, the backups folder, and there is .history folder. And if you use the external Git control, version control, you don't need the .history thing, so I disabled it. So be aware that your projects of 10 megabytes can be in a folder of 100 megabytes because of the backups and the .history thing. So yeah, a small tip. Okay, let's get back to this. Temp is helpful. Okay, I corrected. Non-stock components. Yeah, that depends on the distributor. This is pretty, let's say, commodity thing, well available, and the PMIC can really be an issue. Pretty well available. That's okay. I think Mauser, exactly. It's okay. It's or even helpful. Yeah, can be helpful, but be aware that there is no only Mauser on the market. Yeah. Low stock components, definitely. Maybe you remember in the part 2 or 3 when I sourced the components, the DDR3 and 4 where memories were big issues. So definitely a good point. Yeah, without the previous history of the component sourcing as we have done, definitely helpful point. Inexact part number matches, which is like medium importance thing, and parts consolidation. That's pretty good point. That's pretty good point, yes, because there is majority of BOM consolidation is one thing that we have to do. And the best thing is here. If you check this, and if you, I don't know how to remove these extra attributes. I don't know. Yeah, I tried last time. Yeah, you can go here, update symbols. You can update all symbols without values because it will destroy our test points, and you can check that the remove fields, if not in library symbols. My library symbols definitely contain the attributes visible in the BOM, and reset fields if empty. Okay, so let's try this update. Okay, and let's call the BOM tool again. BOM tool is closed. Still there. Okay, so let's try another thing. Let's try only remove, not reset. Update, but all symbols. Okay, let's get back to tools. Still there. Again, the third option, only reset. I think it's nonsense, but let's check it. Yeah. Still there. I don't know what the blue background means. I can't do a group selection, so it only helps me to focus probably. I don't know, maybe some bug. Bug number 126,000 in the version, KiCad version 10. Yeah, and why? Because we have to have a big major version each year. Even it's a piece of crap, we need it. Okay, so it doesn't matter that I checked. Okay, include, okay. Okay, I was wrong. So now I have to remove Y bar 1. Please don't get me wrong. I'm not mad with KiCad number 10. I'm not mad with software engineers of KiCad. I am mad that the software quality assurance is definitely missing there in the software development of KiCad. And I'm angry with the fact that the software is being developed for, I don't know, for the work itself, not for developers. I haven't been asked if KiCad works well for hardware design. No, we are always served with new useless features that looks fancy on paper but are useless in practice. That's what makes me angry. And the result is the number of bugs in the KiCad. If you work multiple hours a day, every single F asterisk day, then you get easily met with KiCad number 10. Yeah. I'm trying to make some UX improvement of this. It's always in the middle of the screen. Maybe this saves 1 kilometer of running over my screen with the mouse cursor. Yeah, it's not a bug, it's a UX issue, but yeah. And even now I'm trying to pressing the left arrow and right arrow, and you know what? You can see what this is not moving, so you can't. I don't want to get angry with anything. Okay, so yeah, let's try this. Update all symbols with this and check our BOM tool. Okay, it's clean now. At least this works. Okay, BOM consolidation. This is something we should focus, not these components. These components are 35 in quantity, completely okay. These components with one piece can be an issue because for every single component of this, the service engineer or the service worker at the manufacturing floor must include the cassette with the components to the machine for every single one. So if we consolidate the components, it can be a big improvement. I think this is the bouncing. Yeah, that was my issue. Okay. So we need 100 nanofarads but with different package, yeah. Oh. Yes. This one? No, this one. Yes. What just happened? Change symbols. Oh, yeah. Okay. This. What's the maximal dissipation power of this resistor? We have 3.3, we have blue LEDs, which is like 3 volt forward voltage. Let's say even if 1 volt is to be disappeared at the resistor, divided by 100 is, okay, it can easily be 0.402. Yeah, this one. Yes. What else? $100 pico. Yeah, this can be used easily. I will keep this because it's from the reference. Yeah, and let me correct that. It's not power output, is output. It can be both input and output, so I will set passive. And I'm going to check to change the power entry. Probably this one. Okay, let's call it again. One 10 pico, which is here, okay. 10 nanofarads, only one, okay. The LEDs, yellow, blue, green, orange, red. Yellow here, blue here, green here, yeah. This can be this one. And even this, and even this one, because I'm doing this. I think we don't need so many colors. Oh, this is yellow. So this will be green one. Yes. So we have this is 5-volt ESD, which have some alternative ESD. In the bomb tool I should see. This is the array, 3.3, 18 of them. These are 3.3 ones. Okay. Text field. Table. Okay, that's fancy. Yes, bomb tool. So only one ESD. I was thinking that I can connect two 3.3 ESDs in series, which is not great. Which is nominal voltage of this diode. What's the name? 240, 24. There is some capacity of the ESD diode. When I connect two together in series, I can get higher total voltage. The capacity goes in half. Yeah, I will do that. You can call me crazy, but what else? That's header. Okay. 240, it's here. Yeah, we need this, definitely. 10 nanofarads to 50, and I can see 10 nanofarads to 25. Okay, that can definitely be consolidated with the better one. 50. Perfect. Yeah, plus. I don't. Okay, last thing to KiCad number 10. KiCad used to be called fast. Version 10 should be called slow. Every single save takes a few seconds. Thank you, engineers. You are doing good, great job. Zero ohm. 0 ohm. 0 ohm. Okay, we have 14 0 ohms, 04, 02. We have 5 0 ohms. Yeah, that's for my let's say convenience. And this one, I don't know what's the maximum current of the 0603. The dissipation is 0.125, which is funny because there is 0 ohm resistance. So I don't know what's the maximum current. The datasheet reads 0.125 is the typical max dissipation power for the 0603 range, but the 0 ohm resistor has the 0 nominal resistance. So let's check what AI thinks about that. I don't know what's the real 0 ohm resistor resistance. I think like 10 milliohms. Yeah, there is a resistance of the connection, like soldering, pad to PCB, pad to component connection. Pulse load in watts. The rating, nonlinearity, current noise. Yeah, what's the answer? Yeah, 1 amp typical current. Yeah, exactly. 1 amp makes 50 milliwatts, but we have Okay, I will use it. It was R106 before. Yeah. That makes me happy that we can get back to the unused position. Yeah, that's something that makes me happy. Okay. This one must be there. Must stay there. Probably. Yes, 1K5. 10K. 1K2. Frankly, 1K5 for I2C is not much. I can even go higher to 3K3 or something. PMIC, no, this one. Is there a recommendation for I2C pull-up resistors? I think 1 to 10 is an average value. We have 1K2, that's one possibility. We have 3K9, that's other one. I tend to use 3K9 instead of, and we have 3. Okay, we have 3. We have 3, so we have to check R62. Yeah. This one should be 1K2. Yes. Okay, it stops working because I didn't pay. No. Yes. Okay. Okay, so then we can continue for hours. But I think at least a few nonsenses were removed. Okay. Okay, great. So probably I'm going to, yeah, there is an answer. Yeah. It's 3.3, so it goes even to 4K7. Yeah. Yeah, there will be a short distance transmission line between the, not even transmission line, like tracks. It's fine. That's completely fine. Okay, so BB circuits, thank you for the review. It was helpful. These last two can't be marked, but very helpful. Thank you. And next time I will start the PCB layout. Thank you for being here. Thank you for, today is a little bit shorter, but I have to go traveling. So I apologize for my temper about the KiCad number 10. But yeah, you understand probably. Thank you. Thank you for being here. Thank you for the comments, and see you next week. And if you don't mind my constant angriness to KiCad developers, and if you want to support me, there are two courses I created these two tutorials available on fedevel.com. KiCad for Beginners, Essentials in KiCad. You will design this PCB with the buck converter. You will learn how to create symbols, footprints, assign 3D models, graphics to the PCB, PCB layout, of course, manufacturing data export, BOMs, everything in here. Everything is in here. There is a special promotion. You get your board for free, but not only PCB, the entire PCBA. If you enroll this tutorial, you will receive a coupon you can redeem at nextpcb.com within 30 days of the enroll date. And then you can order, as I said, redeem and order the entire PCB assembly at nextpcb.com. So you will receive your board with components for free. The same is valid here. A rather more complex board, a dual-core MCU, 2 power supplies, 2 USB Type-Cs, SD card connector, M2 connector, 4 analog inputs, a bunch of other things. The same promotion. If you enroll the course, you will receive the coupon you can redeem at nextpcb.com, and you will receive your PCBA with the components for free. And when I worked on this special promotion, I calculated the average BOM price for this PCB, and this is about €100 or $100. And if you can check, the price of the course in online version is €69, which is like $75. So you will earn, if you would enroll for $75, then you will learn something, and in a month you can order, or maybe even shorter if you learn faster, you will receive your PCB with $100 value. So yeah, that's something up to you. Thank you for your attention. Thank you for your presence here. If you don't follow me, please follow me on YouTube. If you like this video, like it. If you are angry with me, comment. Please hit the dislike button twice. Thank you for being here, and see you next week. Bye.